Welcome. Today we're going to talk about geometric sequences and series. That's 11.6. A geometric sequence is a list of terms where the ratio of any term to the previous term is constant. Previously, we were adding the same number over and over again to do an arithmetic sequence. Well, in this case, we're multiplying by the same value over and over again. This common ratio is R, which is found by taking the second term divided by the first term, or any two consecutive terms, the later term divided by the earlier term. So the next thing is to tell whether these two sequences are geometric. Probably the easiest way to do that is to try to find R, in this case 16 over 32, which reduces to 1/2, and then see if multiplying by 1/2 gets you the next term for every term shown. In this case, half of 32 is 16, half of 16 8, half of 8 is 4, half of 4 is 2. It does work. So therefore, yes, it's geometric, and R is 1/2. Now, in this one, when I try to find R, 2 over 1, which would be 2, 1 times 2 is 2. 2 times 2 is not 6. So the first time it doesn't work, you know it's no good. So this is no, definitely not geometric. All right, let's take a look at the next thing in the list here. A rule. To find a rule for a geometric sequence. The nth term of a geometric sequence with a first term a sub 1 and a common ratio r can be found using the following rule. A sub n equals a sub 1 times r to the n minus 1 power. So we are going to write a rule for the nth term of this sequence, the one we saw earlier. So first R, 16 over 32, or 1/2. Good. All right, now that we know what R is, we also know the first term here. So A sub n equals the first term times R to the n minus 1 power. All done. That is the extent of how you do these. There's no simplification needed. You are done. And by the way, don't try to multiply these two. This is being raised to a power. You can't multiply these two until after the power has been applied. Can't do it. All right, next is finding a common ratio, finding the rule for the nth term given the common ratio and a term, a particular term. After that, we'll show the skill of graphing. So in this one, a sub 4, so we don't know a sub 1, I'm going to erase this in a second, times r, we do know, to the n minus 1 power. Now this is 4 minus 1. All right, so 54, I'm going to replace a sub 4 with 54 because that's what it equals. And so therefore 54 equals a sub 1 times 3 to the third, which is 27. And if I divide by 27, I'm going to get my answer. Now, I know that 9 times 6, so let's see, what is that? Can't think today. Yeah, of course it's 2. 2 is a sub 1. All right, now I know that a sub 1 is 2, so therefore a sub n is 2 times 3 to the n minus 1 power. All right. I just did 2 to the n when I did mine. So that's all wrong. Let me fix that here. All right. Points. N, A sub n. 1 we know is 2, because A sub 1 is 2. Of course, if I put 1 in here, that's to the 0, which makes this 1 times 2 is 2. 2, well, that makes that 1. 3 to the first is 3 times 2 is 6. 3, that's 2 times 9, 18. And there's not really a point in continuing to go further. It's off my graph by a fair amount. So if I plot these points, I've got 1, 2, 2, let's see, 1, 2, 3, 4, 5, 6, and there's 10, so 18 is somewhere around there. And if we were to draw the graph connecting these, which is not what we're doing, but you can see this is a curve instead of a straight line like the last one. This is geometric, or really it's more exponential to me, because it's an exponential function. Okay. There is the graph, and remember you don't connect these because only the dots are the graph. All right, last slide, the sum of a finite geometric series. The sum of the first n terms of a geometric series with a common ratio r cannot be 1, is given by the following formula. S sub n equals A sub 1 times 1 minus r to the n over 1 minus r. This can get very complicated when you start getting fractions in there. So let's take a look at this one. If we're doing the first 10 terms, that's S sub 10. The first term is 5, so 5 times 1 minus r. Now we saw here, you can find here, that r is the second term divided by the first term, or 2. 2 to the n over 1 minus 2. Okay, there's your formula. All done out. Let's continue. 1 minus 2 is negative 1. And 1 minus 2 to the 10th is 1,024. Oops, let me fix that. 1 minus 1,024 is negative 1,023 over negative 1. I have to move this down a bit. There we go. All right. That's going to be positive 1,023. So S sub 10 is going to equal, I believe it's 5,115, but I'm going to double check. 5 times 1023. Yep, 5,115. So that is the sum of the first 10 terms. You could add them up by doing out the first 10 terms. But the formula is there to make your life easier, because some of these are going to be much more difficult to come up with the next 10 terms or next 100 terms. Maybe it's 1,000. It all depends on what you're choosing. All right, that's it for today. So enjoy your day.